And our topic is decision tree on the wine dataset, and I have Subhash,
Hello.
Eamon,
Hi, guys.
and myself Yash Patak and Piyush Sharma.
Hello.
And our agenda is basically first we will talk about the objective, and secondly we will go for scope. Then we will talk about the machine learning and the AI topic, for which we are talking about the decision tree right now, and then we will talk about the cloud environments. So basically we have implemented our project decision tree in three platforms, which are the Azure, AWS, and Google Cloud Platform. So then we will talk about the analysis, that the result that we got for the decision tree, and at the end we will talk about the conclusion. So mainly our objective is to implement the machine learning algorithms in different cloud platforms, such as I already talked to about you about the Microsoft Azure, Google Cloud Platform, and Amazon Web Service. And we will analyze the wine quality data, which contains the red wine data and the white wine data. So we will run our algorithm on that, and the decision tree algorithm in that, and we will analyze the our model, that how accurate our model was. That our basically our scope will be talked by Piyush Sharma.
Hello everyone. So I'm here to present the scope of our project. So basically, as my teammate just told you, that we are implementing decision tree and three different platforms. One is Azure, one is AWS, and one is Google Cloud Platform. These three platforms are high demanding in the IT at this time. So the scope is the basic implementation of the decision tree algorithm, as my teammate told you about that. That we have implemented decision tree in three different platforms. The three main platforms that are used in the infrastructure in today's world. So we have used an algorithm that has is only applied to the wine quality data set. So we have gathered the wine quality data set from internet, and we have applied algorithm on that, audition tree algorithm on that, and the results were we got results in three different platforms. That three were all different. So uh, and the basic of the MLAI topic. So decision tree is basically a branch of supervised learning. A decision tree is basically a regression or a classification model. Decision tree are basically in a tree structure. Like uh, they have like decision tree uses database that cuts into small subsets. This results in a decision tree and leaf nodes. The decision tree has two or more branches. The decision tree leaves node represent a classification or decision. The top node in the decision tree correspond to the best predictor, which is the root node. The decision tree can handle both categorical and numerical data. So we have used both numerical and categorical data in our dataset that we are going to implement. So Subhash will take over from now.
Hello, everyone. I'll be talking about the cloud and Azure environment. Uh, for this one, we actually implemented our project in three clouds that actually predominates the entire world. It's actually Azure, Google Cloud Platform, and AWS. Uh, in Azure, in Azure, actually, we in Azure environment, actually, we took the data and then we checked each and every field from it, and there were actually more than one fields. There were fields like fixed acidity, volatile acidity, citric acid, residual sugar, and then the pH values and alcohol content, sulfates, and all. So based on all these parameters, we actually had to make decision, and the decision was made against the quality, which contained data from 1 to 10, 0 to 5 meaning it's low, and 6 to 10 meaning high. After getting the data, we look for if there were any outliers and if there were any null values. So while checking that, we found out that there were no any null values and there were no any outliers. So for this purpose and for this data, we didn't actually have to clean our model, or we didn't have to do anything with our data. We didn't have to manipulate our data. After verifying the data is clean, we actually split the data into two parts: training the model, train data, and then the test data, which would actually test the trained model. The split was based on 70-30. And then after splitting the data, we implemented two-class decision forest. Actually, Azure provides one more feature in combination to the decision tree, which helps us better configure decision tree for best result. It is called Tune Model Hyperparameter. Tune Model Hyperparameter in Azure Machine Learning Studio is used to determine the optimum hyperparameters for a given machine learning module. This module builds and tests multiple modules using different combination of settings and compares metrics over all the modules to get the better combination of settings. That is why implementing in Azure was much more easier for us and also gave us better result. After tuning our module, we build our module and then we passed our test data. Uh, uh, the test data, and while evaluating, after the test data was passed, we evaluated our module, and then we found out that our accuracy was 95.5 percentage. So from here, uh, Ayman will be taking on.
So after we implemented the algorithm in the Azure platform, we got an accuracy of, as you can see, 99.5%. And we have had some false positives, which like 9 false positives. And um, generally, like, th this algorithm gave a really good generalization of the whole thing because in a decision forest, like the overall learning is considered. Basically, inferences from different decision trees were taken into account, which is why we got a really high accuracy value for our model. Next up, we implemented the same algorithm, but this time in Google Cloud Platform. As you can see that we have used traditional libraries from Python, such as scikit-learn and NumPy, and mainly we have like used scikit-learn for our uh, to import our models, and after we have implemented it in Google Cloud, we have had an accuracy of 92%, 92.5%, as you can see here. And basically, we kept all of our parameters the same. Even for the cloud platform, the test size was 30% and the train size was 70. So uh, we kept everything constant. We then implemented the same decision tree algorithm in Amazon Web Services, and all other parameters remain constant. And um, after we implemented it, we found out that the accuracy still remained the same because we implemented decision tree in AWS and Google Cloud Platform, and the accuracy was 92.59%. Um, so overall, if we have to draw a conclusion amongst all three platforms, we found out that the Azure platform gave us the best results because we in Azure we implemented something called Decision Forest, where it's basically taking a random subset from the main data set and then it's running three multiple decision tree algorithms and then aggregates the results together at the end, which is why we are getting higher accuracy for Azure, but lower accuracy in Google Cloud Platform and AWS, where we did not implement the ensemble learning method. So overall, from our understanding, we found out that the Azure platform performed the best for us, and we got a 99% accuracy there. And in conclusion, we have implemented the algorithm in all three platforms, namely Google Cloud, Amazon Web Services, and Azure. And after all services, we have observed that Azure is far better compared to the other services, and Azure is much more convenient to understand and easy to use and very modular, which is why it's like a really user-friendly platform as well. It has barely any setup required to it. And we also found out that our model in Azure performed better than the other platforms. So this was a defining factor for us. Thank you.
Thank you, everyone.
Thank you, everyone.
Thank you.